alternate interior angle theorem. I don't even know if we touched on this yet. Do you know what this is?
This is way easier than the words make it look.
Oh yeah.
You learned it, but you didn't learn it according to the words.
So alternate interior angles would be 2 and 8.
Probably. I think you said it so confidently that I just have to assume you're right.
Yeah, I just didn't. It's just the word theorem really like.
Okay. It's like the same thing as proofs. Like as soon as you call it a proof, it's like, no, actually, I don't want anything to do with this. You're like, but it's just basic algebra. All right. I'm just gonna do the numbers here really quick. So we have 1, 2, 3, and 4, which are obviously not angle measures.
No,
they're just labels. 6, 7, and 8. They could just as easily be A, B, C, and D. Okay, so alternate interior angles theorem. Which one did you suggest?
I just did 2 and 8.
2.
Because they're on alternate sides of the transversal, which we could just say it's like A or something. Right? No, it's J. And then this is I and that's H. But they're on the inside of H and I.
And I think that is a perfect way to describe it.
Yeah,
they're on the inside, so interior, they're on alternate sides. So then what's your next question they ask you?
Alternate exterior angles theorem, which is just the same thing except on the exterior of H and J or H and I. So I'll just say like 1 and 7. I think that works.
Sure. And there is some truth, some like we'll call it a rule, but it's I hate using the word law in math because it's not arbitrary law. It's not like designed by someone written down in words. It's more just emerges from the fact that you have 2 parallel lines, and when you have this transversal coming down, what's true about angle 1 and angle 7 relative to one another?
They're on either side of J.
That this is true. They're on either side of J. Let's say angle 1. Roughly, what is that angle right there?
Probably like a 120 maybe.
120. It's more than 90, right?
Yeah, exactly.
So like 120. So then what do you think this angle is right here?
It's 120.
120. So that's what the actual theorem is saying, is that there's this property. Property is way better than law. Let's go with property. Okay. There's a property that if you have a transversal cutting only through parallel lines, if these lines are even slightly off parallel, property doesn't work anymore. But essentially you get the same angle 1 and 7, and then you'll also see a similar truth with like 1 and 4.
Yeah, so with this it wouldn't be the same.
Yeah, these are just slightly off parallel.
Yeah, got it.
Which I literally think of this as like 2 edges of paper that if you brought them together, it'd be one line. And then as soon as you kind of spread them out, it's like the same properties, but just add a gap.
Yeah.
Kind of.
Yeah. Right. And then for the next one, same side interior angles. So it's just on the same side of the transversal, so like 2 and 5 per se.
Okay, so
that's like same side interior angles since it's on the inside, you know. And then corresponding angles. That one's like 1 and 5, I believe. Corresponding.
Let's just do this.
Yeah.
More football as it goes.
Because they're on the same side of like each. They're like both on the. They're both on the left, and they're both on the same side as the transversal.
Were you right?
Yeah.
All right. There you go. Yeah, it's the rules of what's equal and what's not equal, and what adds to 180 and what adds to 90 and such. You'll start to get a very intuitive feel for, and you might eventually drop some of these definitions, but they are like the technical definitions of the properties that you're going to start to play with a lot in these lines.
Yeah.
What's true of like what am I doing here? What's true of like 2 and 6?
They're corresponding.
They're corresponding. What does that mean about their angle measures? The angle measure of 2 compared to the angle measure of 6.
I mean, so they're in this example, they're corresponding and congruent because we know the lines are parallel, but like they're not always congruent.
Congruent, and by congruent you mean
like
same measure.
Yeah, exactly.
So in what case wouldn't they be congruent?
If it was like if angle H was like angled like any differently.
Right. So in the parallel lines case, you're saying that's true.
Yeah. Okay. But like, you know, A lot of these two are still corresponding, but they're not congruent.
I see what you're meaning. So you're giving me the general case of what corresponding means, and here you're giving me the property of corresponding angles when they're paired with two parallel lines.
Yeah, exactly.
Okay, yes, very specific. I like that. Again, that kind of like folding thing. If you folded H and I into one line, angle 2 and angle 6 would literally be the same, like
exactly.
Same exact angle right on top of each other.
Yeah.
Okay, cool. So now you have to write some of that stuff down.
Okay.
You can start with the examples because that's where you were talking first.
2 feet. I just touched that. That probably like a really loud noise.
It's a low budget film here.
Yeah, didn't you get all this like pretty much for free?
My room, it's my roommate's. Okay. So I'm liable to pay for it.
Yeah.
If I break it on accident, but yeah, as of right now, it's a nice gift of a loaner.
Seems like 2, 5 corresponding to 6. And then he said we don't have to write down the definitions if we like can look at the example and like put 2 and 2 together.
Okay, there is one thing that you could write for each of these as like I don't know if you would write it in the definition or the example, but talk about the measure of those angles either relative to one another or in a different case where maybe you're talking about the measure of them if they were added together. I don't even know if we did that one in here though. I think we did all. So like for this one, for example, what is true for alternate interior angles of parallel lines?
They have the same angle?
They have the same angle. So the angle, I would write that like angle 2 equals angle 8 rather than just 2, 8.
Okay.
Right. So that's just like a one step further in your example or your definition to actually show why this is useful.
Okay. So would that, you think I'd kind of, if I just wrote that down in my definition?
You could write that in your definition. That's fine. It's probably better than nothing. And it's probably going to look similar for like something like 1 and 7, I think was one of your examples. Then
you can't really do that with the third one.
So 2 and 5. Now this one is interesting though. 2 and 5 do have something special about them.
They add up to make 180.
Oh, boom. There you go.
So yeah.
Angle 2 plus angle 5 equals 180 degrees, which could be visualized any number of ways, like you ski, right? We've talked about this. So 180, you start forward and land backwards, and it's kind of the same here, but the turn that takes you to going backwards is on this like jagged path instead of a smooth rotation.
Yeah.
But it's still that like 180 degree rotation around. Or you could, go as far as to actually look at like, what are the chances that I can actually make this happen? Let's see. Okay, there's 1. Just got to prove it since we're here. We said that and 2, right? All right. Now we got to take this bad boy.
You should get sponsored by this app. That's the goal.
I wouldn't mind. I do love this app. Let's see.
Yeah, seems
not bad.
Legit enough.
There we go. All right. That's my visual proof.
Mm-hmm.
I'm going to get even faster with that in the future. All right. I think what they should do, and I don't know if I just haven't figured it out, there should be a way to like, I don't know, but for like lock whatever you've drawn on there, so then you can erase and draw on top of it without messing everything else up. But anyway, feedback. All right. That's not bad. We're gonna start using that to solve like bigger drawings with lots of lines and angles together, something like that.
Yeah.
Oh, and they throw in the algebra.
Yeah, that's when it gets rough. But practice each corresponding angle. ABC. It's 180. Right.
We're doing this one here. Measure of angle ABC.
Yeah.
Yeah, so that's.
And if they're corresponding, and those two arrows represent like parallel, so we know they're the same.
So point to what letter should they use to identify this angle on here, this missing one, ABC?
That one? Ooh.
It's that little X?
Yeah.
So does that angle right there look like 180?
No.
Not quite.
Oh, no, I said 80.
Oh, you said 80.
Yeah.
Okay, I thought you said 180.
No,
I, said 180. I thought you were like adding the 80 on or whatever. These are parallel. That's 80. What was the theorem called again?
Corresponding.
Sure.
Yeah.
All right, that one's easy.
So
80 it is.
simple enough.